buffer solution is the acid-base one with a common ion. I'm sort of putting one significant figure just to get it done here. If I have 0.1 molar sodium acetate in 0.1 molar acetic acid, Ka 1.8 times 10 to the minus 5. That's sort of the way you see it on a quiz. What's the pH or what are the concentrations of the various ions? And what happens is, stoichiometry first. This started out as 0.1, this is 0.1, this is 0.1. Then we do our equilibrium. Again, here's our common ion effect. Starts out as 0.1, not 0, as it did in our other problems. Okay. Yes?
I was wondering, what happens if it's a, instead of being like a metal with a 1 charge, like Na, if it was something that had like a 2 charge, like Mg, and you had more than one of your conjugate base, or base rather?
This is what you're asking, right?
Yes.
If this is 0.1, this is 0.1, what's this one?
So that'd be 0.2.
0.2, yeah.
Okay.
That was, where did we see that? Back when we were calculating concentrations of ions when we were doing the 60 drops, so 60 over something or other calculating drops. I gave you the problem where I had more than one ion, more than one cation. That was that problem. So that's the number that would be the starting number. So anyhow, there's the common ion problem all over again. Now when you do the C, E, so basically what your problem becomes, this is a case of A problem, but I can do the same thing for case of B. X, and I'm going to call this number because it doesn't have to be 0.1, it's going to be some concentration. C prime plus X is the concentration of the source of the common ion. So it's that problem. All buffer problems break down to that type of problem. If it's a base, this is case of B, the X would be the hydroxide ion. The C prime is always the conjugate species concentration. And the math for this is really easy, because you always do it by approximation. Coming back to this thing, for instance, right here I did it, but I didn't really emphasize it to you. The amount we ignored, 1 times 10 to the minus 5, was much smaller than the original amount, so we were justified in making that approximation. And the same thing is going to be true in these buffer problems. It's going to be 1.8 times 10 to the minus 5. And I picked easy numbers for myself. And notice I'm not canceling. People always say, oh, you canceled out the x's. I'm not canceling them, I'm ignoring them. That's what you do in approximations. Because they can't mathematically cancel out in that way of writing it. They don't cancel out. Just ignoring them. If I can ignore it here because it's smaller than 0.1, it's also going to be smaller than 0.1 up here, so I can ignore it there. And notice what happens now. That's why I like this. Can't make a mistake here. X is 1.8 times 10 to the minus 5, because now the point ones do cancel out. Or I can divide it if there are other numbers. So 1.8 times 10 to the minus 5 is much less than 0.1. My approximation is justified. And now I can go on and do the rest of the problem, either calculating the pH or the concentration of each thing. Now, a buffer solution, and I'll do a lot more with this. As I said, I might get common ion on the exam. But a buffer solution is made up of a weak acid plus a soluble salt of the conjugate base. It's an insoluble salt, it doesn't do you any good. So this was acetic acid. And the soluble salt of the conjugate base, I chose sodium acetate. But as somebody said, I could have picked any other acetate compound, because what's the solubility rules for acetates? All acetates are soluble except silver acetate is slightly soluble. Okay, so we could have picked any other acetate source. Or it's a weak base and the soluble salt of the conjugate acid. Classic example, NH3. Ammonium chloride is soluble. The problem we run in here, most of them might be nitrates, because the solubility rule for nitrates, they're all soluble. But when you start getting to other things that you put in there, and you don't want to put acetate here, because then you have a much more complex species. So it has to be something that's, even though it's soluble, we'll talk about hydrolysis after the exam. But these are the way you recognize them, and this is the basic problem, and we'll come back to it next time. Okay, I'll see you.